Yo, cool. So yesterday we talked a bit about like the mechanics of creating classes and methods, and today we're gonna be talking about why. Um, Joe M. Can you give an example of some a type of object and specific instance of that object that you discussed in your breakout room?
Yeah, sure. My partner Logan and I went with dogs. The
Yeah.
first thing on our minds with our dogs wandering around. And then so that was our class. And for instances, we went with breeds then
Hmm.
from there.
Cool.
Sorry, was there another
And
another part to that?
no, no, that's great, right? And the idea is that like we have a dog, but we have like the less so breeds, but like more of, like specific instances. Like an instance of a dog would be your dog, and a different instance would be Logan's dog. Like going back to the ubiquitous car example, right? Like I could have a Ford Escort, and so you could have a Ford Escort. I don't know why, but that's a possibility. And they're both Ford Escorts, but like mine's different from yours. Like mine could be blue, yours could be green. Different mileage, different options. Like I could have the luxury package. I don't know what that would be on a Ford Escort, but you get the idea. Like they are the same thing, but there are differences between the two. They have different states, and the big kind of picture. Pardon me, as I take my toy away from my dog, and she's making noise, and now she won't let it go. Hey, I give up. But I will show you the best trick I've taught her. Athena, retire to your chambers. Cool, that works. It's fantastic. As I was saying, the idea is that the whole big picture of object oriented programming is that we create these objects to kind of reflect real life. And when we create objects that reflect real life, I think that it's easier for us to understand, right? Because we interact with objects in real life all the time. Like you are on a computer, presumably because you got all your computers from Turing, they are like the same computer, but they are different in that like yours is unique. Some of you have made decorated with stickers, some of you made a little different software. And so when we create these classes, right, we're trying to copy something that exists in real life. And in programming, a class is something. Ooh, let's make some notes. And I also want to note about my notes is that I am not great about remembering to post my notes after class. So, like, if you could help me, if I haven't posted my notes immediately after class, just pop a message in Slack and just let me know I haven't done that. So, classes, they model two things: state and behavior. To use this idea, let's say going back to the car, things that model state would be like my car's green, your car's blue. They do have a color, but they are different depending on which copy you're talking about. Behavior is something that all things share. So like gas pedal could be like a behavior. Like gas pedal makes the thing go. Right? And so importantly, oops, state is what something is. Behavior is what something does, right? In this example of that refrigerator that we had when we started this whole discussion, we modeled the state of the refrigerator by saying like a refrigerator has a brand, a color, and a temperature. And the behaviors of the refrigerator are add food, remove food, and change temperature. And so these other terms that we need to know is that an instance or an object is a concrete representation of a class. It's capital C class, so it stands out. Right? So my Ford Escort is a specific instance of the Ford Escort class. Your Ford Escort is a specific instance of the Ford Escort class. And so we have like these instances of a set object, right? And like I think we used this term yesterday, where a class is like a blueprint, and an instance is the actual kind of thing. So like over at the factory, Ford has the blueprint for the Ford Escort, but we have actual copies of it. Questions so far? Dun, dun, dun. Cool, cool, cool. All right. Oops, I actually wanted this on this side. So we saw yesterday the syntax we're defining in class, and we do that like so. Class, oops, not ass, name of class, right? We define a class by, not MD. This should be running RB, my mistake. Get that fancy syntax highlighting. We define a class as follows. We have the class keyword, the name of the class, and an end. So like this is the basic syntax, and for example, to use Joe's example, if we want to make a dog class, oops, we do like this. We want to note that like for classes that have multiple words in it, we want to use upper camel case. That's where the first letter of every word is capitalized. And that's what we're going to do. Like usually, I think most of the time, classes are single words, like dog, cat, car, whatever. But in the case that you have to have a multiple word class, use upper camel case. And so the example we're going to use is that we're going to create a unicorn class, kind of example. And what we're going to do is that when I want to make a unicorn class or a class of any sort, each class belongs in its own file. So because I'm making a unicorn class, I'm going to touch unicorn.rb. Here, open it up, unicorn.rb. And we're going to do class unicorn and like so. It is important that your class names match the class inside. The idea here is that we want to follow what's called the principle of least surprise. Where you want to, in your code, do the least surprising thing. So the fact that I have a class called unicorn, and it is found in a file called unicorn.rb, is least surprising. However, if I made a class called unicorn and I put it in pizza.rb, that would be pretty surprising. Like, why would you do that? You know, it's like you're kind of obfuscating, you're kind of hiding code. You know, like let's imagine your first job, you get on a thing like, yeah, we need you to fix this bug in the dog class. And then you spend, the principal of least surprising, like, okay, dog class, cool, it's going to be dog.rb. And you go look for it, and like, oh no, there's no dog.rb. And then you ask someone and say, oh yeah, dog class, that's in cat.rb. Like, why would you do that? And, it's kind of like you're adding like extra layers of complexity for no reason. So in general, not even in general, I would say always. I can't think of a reason you would not just always do this. But whatever class you're working with, you name that, you choose the file name. The file name should be the same. Cool. All right, I'm gonna go and I guess any questions about the naming of files and naming of classes? I think that's a pretty important point. Like, we always want to see the two match up. Fantastic. Cool. So I have this runner.rb file. And what I'm going to do is that the runner.rb file is the file that kind of run to make things work, right? And so what I want to do is that I want this run file to instantiate myself some unicorns for myself. And the first thing I'm going to do is I'm going to do require unicorn like this. What this says is that, hey, when I do a Ruby runner.rb, when I type that in enter, it's going to check the runner.rb file. And what it's going to do is that it's going to see this and say, hey, require unicorn. Require says like, hey, I want you, computer, to go look for this file and load it in. I want to have access to this. And so the // means is from the directory that I'm running the runner file in. The runner file, runner.rb, and unicorn.rb live in the same directory. So what is saying is like, hey, in this directory, look for the unicorn file. We don't write .rb because it's kind of assumed that you're referring to a Ruby file because you're working in Ruby. So it's going to look for unicorn.rb file, and we do have one in there, and it is going to kind of load that like, hey, I know where this is. Next thing I'm going to do is I'm just going to create 2 instances of unicorn. Dun, 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 unicorn 1 equals unicorn dot new. Nope. This is what happens when you don't type right. One equals. I am struggling today. And what I'm going to do here is that I'm going to require pry, because I want to show you how to do some stuff with it. And down here we're going to do a binding. Why do I keep hitting the undo button? Cool. And when I run this, why is this not working? Weird. Mm-hmm. Oops. Bear with me here. Why aren't you working? Interesting. I'll troubleshoot this later. But the idea here is that when I do unicorn, let's do a require unicorn, and I do unicorn 1 equals unicorn.new, and I do unicorn 2 equals unicorn.new. Right? We see here that unicorn, I type in unicorn 1, I have this here, and this here is like the kind of visual representation of an object. This is kind of like, this is what we can kind of consider like this unique identifier as to which object this is. And we do unicorn 2, we see here that it is a different ID. So how are these two things the same and how are these two things different? Alexander B? Oh, you're muted.
Sorry, what was the question?
How are they the same and how are they different?
Unicorn 1 and 2?
Mm-hmm.
I mean, they're just 2 different instances with 2 different names. So They're the same in that they're exactly the same, like unicorn instance. Their value, I guess, is the same, but they're you've defined them as two separate things.
Right. So what they are is that they are both objects that have been instantiated from the unicorn class, but they are two separate unicorns. It's kind of like if you have right now, if you have two different cars that are that just straight off the factory line, they're the same color, they are the same like 0 miles on them, same like features or whatever, but they are two distinct objects. They're identical for all intents and purposes. They are identical, but they are two separate items. Cool. Questions so far about the syntax? Joanna.
Yeah. So looking at the require slash unicorn, and then it returns true when you're prying in there. If that were to come back false, that could be because the file is not saved in the right location.
Yep. In general,
Okay.
so when it comes back false, I think that it would give it. Let's see what happens if we try to make it not work. Right. So we'll do a require elephant. Right. It doesn't quite return false. It just say like, "Hey, I can't find the thing." The true is simply like it's saying like, "Yep, got it. Everything's cool." But when we try to load something, it doesn't, it'll actually just kind of throw us an error. It says it can't find elephant in this directory. So you'll get a little more specific thing. The true just saying like, yeah, everything's fine. Cool. Lee?
What's the difference between putting essentially require pry, binding pry on one line versus splitting it up in the way that you did?
I'm sorry, you kind of broke up for me a little bit.
Sorry. What's the difference between putting require pry binding dot pry on the same line versus splitting it up into kind of a sandwich the way that you did?
Yeah. There is no functional difference really. I generally require pry at the top of a file, so then I can just move it around. It doesn't really matter what you do. Essentially the same thing. Con?
Hey, Mike, thanks. So the unique identifiers for each of these classes, what is the format of that called? Is that a hexadecimal format?
It's a hexadecimal format. It's essentially a memory location. You'll probably never use it. It's just enough for you to know that they are unique.
Thank you.
Andrew S. Can't hear you.
Sorry, I'm still a little bit confused as to what exactly pry is, and especially what's the deal with binding dot pry at the bottom.
Yeah, so
I wasn't
what pry
following.
is, it's a debugger, and what it does, it lets you halt execution and open up an interactive pry terminal where you have all the state loaded. Essentially, what happens here is that it is saying like, hey, when we've done all this stuff, I want you to load up an interactive debugger, interactive kind of session like you just type in pry in terminal, but with the previous state loaded. And it's essentially a debugging tool, and we will go into further detail about its use when we talk about debugging specifically.
Okay, so it's separate from testing, the
Yes.
testing stuff that we do.
It
Okay.
is separate. Joey H.
This is a relatively simple question. When you created, I saw you created yesterday like a runner file, and today you created a runner file. Is that like context to say like this is a test file, or is there like
No, a runner
common nomenclature
file,
around a
yeah.
runner file?
A runner file is essentially the file you run to make everything kind of start working. The idea is that your class files will generally not have code that just runs. It's just a definition of the class and only things between the class and the end. The runner file is what like kicks that instantiates objects and kind of kicks everything off.
Got it. Makes sense. Thank you.
Alexander?
Could you open up or just make the unicorn.rb file visible? I missed what you
I'll
put into
it
that one.
over here. It's just class unicorn.
Oh, okay.
Yep.
Thank you.
No problem. Austin?
Where does require look for the files? Like, does it look within the directory that runner.rb is in, or does it look throughout your entire computer?
It depends on how you are doing it. When I do a / at the front of Unicorn right now, it says look from where I am running this file. So for / means if I'm running the root directory, which I am in here, it's going to look for Unicorn there. When I do require pry, it's pretty much saying like, hey, look for the system directories for pry.
Okay, thank you.
Mm-hmm. Boom, boom, boom. Joey? Is that an old hand or new hand?
Old hand. I will take it down.
Alec, oh, okay, cool. Awesome. Let's pause here. Let's take a break. Let's be back at 9:39. Let's be back at 9:39. We'll continue our discussion. Fantastic. So, we have this Unicorn class. Just accidentally type some stuff in there. We have this class here, Unicorn, and it doesn't really do anything so far. Like, it's just kind of this blank class. And the kind of next step is that we want these unicorns to have different kind of attributes, right? Like we talked about how attributes are something the unicorn is, and we want to start adding this. So we want to start adding these 2 attributes to unicorn. So we want to make sure that every unicorn has a name and a color. And what we do is that what we use to model attributes in a class are called instance variables. We define these instance variables in a method called initialize, and initialize is run every single time a class is instantiated. One point to note is that you will misspell initialize, and it will eat up like an hour of your time because you spelled it wrong. So like, be super careful about how you spell that. It doesn't, things fail in like a kind of a weird way when you don't have that spelled correctly. So what we're going to do is, to this unicorn class, we're going to add a initialize method. Let me do this. Just start that up. We have it. Cool. And so again, this method is run once and only once during an object's lifetime. But other than that, initialize works like any other time we use Ruby. It's like just the method. So in initialize puts, we can do puts, hello, I am a unicorn and I have been born. And what we're going to do, oops, sorry. And you see here that it prints out to the screen, hello, I'm a unicorn, I've been born. That's because the initialize method is getting run whenever we instantiate a new object of new instance of unicorn. You could say that new is kind of an alias for initialize. When you do something .new, it'll automatically run initialize. Right? Like we can see here that we've not done unicorn.initialize. Cool. Any questions about how initialize works? Fantastic. Fantastic. All right. So now that we have kind of a handle, like, hey, initialize is what's run, we want to model the state of our unicorn with attributes. These objects that we've created so far are essentially, they don't really do much, right? They just like, we instantiate them. Like, cool, we got 2 unicorn objects, they have these unique IDs, and, you know, and we've said earlier that unicorns have both state and behavior, and so we're going to talk about state. What we're going to do is that we're going to add some attributes to it. We're going to use instance variables, and when we use instance variables, we put an @ symbol before the name. When we put an @ symbol before the name of a variable, it is noting that this is an instance variable. So we're going to change our unicorn class to look like this. Name. Me personally, I like these to line up. Like this. And so what I'm going to do is I'm going to reload. Nope. False means I've already done that. I'm just going to start over. Acquire. And so when because the attributes are something that an object is always going to have, right? This unicorn, what I'm talking about, is always going to have a name and color. Much like a car will always have a color. A person will always have a name and height, right? These are things that will never kind of go away. Instance variables are used to kind of hold on to that information forever. So we have this method class that allows to create different instances of unicorn, each one slightly from the last. So what we would do is that we would create unicorns like this. And I'm just going to change my code up here so you can see what I'm doing. Right. And so when we pass parameters through new, Ruby passes those into initialize for us. Right? And I want to remind you that when we pass parameters / arguments into methods, the order matters. So like for here, sparkle is going to go into becomes name parameter, rainbow becomes the color parameter. So when we instantiate a class like this, the first one becomes the name, the second one becomes the color. What we're doing here is that we're showing that for the second unicorn, let's say a unicorn has no name, and we have to pass in an empty string to kind of like do that. Because what happens is that if we just pass in the color, it's going to freak out. Like, I don't know, I'm expecting two things. I'm only getting one thing. This pattern is something you should get used to, is that when we instantiate a new instance of a class, what we're going to be doing is we're going to pass in like the attributes of it that we want to live with and want to start existing. So like when I instantiate a person class, it should have things like name, gender, height, age, things like that. We give our initialized methods some arguments, and those arguments get saved into instance variables. Questions about this so far? Con?
I was wondering, in your Pride terminal, you've got require a unicorn, and then it was false. And then
Yep.
Could you explain what you did in order to get it to run and return true to you?
Yeah, so what I did was I required unicorn return false because I already had required unicorn earlier. So I was like, nope, you've already done that. You don't need to do it again. So what I did is I quit pry, like right here. And I ran it again to kind of like wipe everything out. And then I required unicorn again because I had made some changes to this file.
Thank you.
Alex F?
Yeah, what if, let's say you run it the first time and it goes false the first time? Like,
It shouldn't.
and if it did, I just did something wrong, one might say?
One, probably. Two, if it did false, I would just quit pry and start it up again and see if it did it again.
Okay.
Usually, if you have a fresh pry session, like fresh meaning like you just typed in pry and enter, it should not give you a false when you try to require something. That usually, if it does give false the first time you try something, it's probably because we made a mistake or like something else is going on.
Okay.
What that something else could be, it would depend on the context. Jahara?
In your initialize method, you listed name first and then color,
Uh-huh.
but in your
Uh-huh.
pry, it came out color and name.
Yep.
Why?
It's a good question. I don't know. I've never actually paid attention to the order of it, but what I'm gonna do is I'm just gonna let's see what happens. I'm gonna put the color first here. Oops, nope. And oops, I'll do that first. Okay. So my suspicion is it alphabetizes it. So what I'm gonna do is I'm gonna do A equals hello. Like that. And we're gonna see if that does the trick. Yeah, it looks like it's alphabetized.
Okay, thank you.
Yeah, honestly, I don't really like this. Is here is just the representation. Like you're just gonna print out, see what's inside. But it really the order, whatever's in there, doesn't really matter because it's not like something that's order dependent. Dougie.
Could the I'm assuming I'm having the same issue as sorry, I can't remember. Was it Joanna? With the require returning false, and I think would that cause any sort of other errors in some of the other pry things, like when I'm trying to.
Yeah, so when you get that return false, it means that you've loaded up, like you've already loaded that file, and you're not. There's probably a command to reload a file. I'm not sure what it is. I'd have to look that up. But that should be fixed just by quitting pry and restarting it.
Yeah, it wasn't. That's why I assumed I just did something else wrong. So I've never gotten true so far.
Okay, let's take a look at that like after class. Lee?
I mine kind of just was piggybacking off of what Dougie just said, so I can wait on that.
Yeah. Let's take a look at that like you have PDF for this, so like let's kind of like let's put a pin in that, and we'll resolve it later today. Cool. Other questions? Cool. All right, let's kind of move on. All right, so the idea is that so we have these attributes that are stored in the method, but like we kind of need to get them out, don't we? Like right now we have no way to access them. So the idea here is that we want to access information inside a class by sending a message or calling methods on the class. And so the idea, like what we want to do is like the great thing about programming is that we can make things work however we want to make them work. So we want things to work by having methods. And so if I have a unicorn a unicorn object, if I want to get its name, what I want to do is that I want to have a method that accesses that information. So ideally what I would like to do is that I want to type in, to get Sparkle, I want to type in unicorn one dot name. Right, I want a method called name that will report me that unicorn's name. And so when we type in enter like this, it says, hey, I don't know anything about a method name. And I'm like, that's cool. And that's happening because we haven't like defined any kind of a name method in our unicorn class. So we can do that. We can update our unicorn to include a name. And it does something like this. Now, when we type in name, what's going to happen in unicorn.name, we call the method unicorn name, it's going to return us whatever stored in that name. So what I'm going to do is that we're going to start over again. We're going to load the file up. We are going to initialize instantiate a copy unicorn. And we'll write them in unicorn1.name. What's going to happen is it's going to go to the unicorn class, look for the name method, and the name method is like, okay, so whatever is inside this instance variable at name, I'm going to return that. And when I hit enter, this would be better if I had saved the file before I started this process. So I'm going to do that again. Okay, now it should work. We see that it returns to Sparkle. And this is how we access the things that are stored in our instance variables. What questions do we have about what's happening here? So to kind of review, to kind of like take from the top, we've initialized a new instance of Unicorn. We've given it Sparkle and Rainbow. When we do that, when it's initialized, the parameters come in here and they get stored into these instance variables. We then call the name method, which we've written, and the name method is like, hey, just give me whatever's stored inside. Dougie?
So just to be clear, pry doesn't, pry only recognizes everything that was done since the last time it was run. So if you add a new method, like to your unicorn class, pry won't know that until you quit pry and then restart it again.
Yeah. There's probably a command that will let me reload a file in pry. I'll probably look it up during the break to make things a little quicker. But yes, what you said was right. Kevin?
Yeah, I noticed your every time you go back into pry, you put the require unicorn file. Do you have to tell it, or are you just checking, or are you telling it to reload again so it's true? Because I'm having the same fault problem with the require the reference file.
Can you say that one more time?
After you typed pry, you typed you entered the command require the unicorn, and it came back true, and then you asked, and then you had to re-enter unicorn 1, and then you're able to check the name that way. But it seems like you're having to re-enter require unicorn.
Yes, because when I quit pry, it wipes out all memory.
Okay, thank you.
Right, it's like essentially fresh start, so I have to require that. Cool. Aiden?
Yeah, just kind of echoing what Kevin was saying. Couldn't you put your pry into your unicorn file and then run your unicorn file?
We could, but we don't want to do that. It's not currently working on my computer. Normally what I would be doing is that I would just be running the runner file. But like it's not working for me right now, so this is what we got to do.
Okay, gotcha. Thank you.
Mm-hmm. Cool. Alexander?
Sorry if we're going slow here. So
no apologies.
Pry, it kind of seems to me that it's almost like it puts everything out so you can kind of see everything that's happening. Is that what pry does?
Yeah.
Okay.
It's a way for us to like kind of pause. Let's take a look at things. This is what or what's everything's doing, and like.
Then that way you don't have to like type puts every time to see what's going on. Perfect. Okay, that makes sense.
Con?
Is there a general format as to where binding would be placed? Would that usually be placed in the assertion side, or is it just wherever I need to?
Wherever you want it to stop. Mm-hmm. And like after this class, I'm gonna like figure out like why this isn't working for me. That's gonna be fun. Cool. All right. So by this same kind of thing, I also want to create one for color, right? Oh, Alex.
I'm sure we'll get there, but can you just talk me through really quickly why you wouldn't just want to put the binding pry at the bottom of it? like you said, you put it where you want it to stop.
Mhm.
And just maybe that's the key that I need to understand it.
Yeah. So the idea why we want to do that is like when it's a little hard to kind of like talk about it now because we don't have that much code. But as your programs get in more complexity, they'll be longer. And the thing is that like you may have a problem in your code, you don't know where it's happening. So you would do what I would call a split half search, where you put like your pry in the middle of something, and then you use that to verify your assumptions. If everything works, you know that everything before that is like good to go, and your search is now narrowed into the second half of whatever you're doing.
Okay, that makes sense.
Ksenia?
So if you don't define name in the unicorn Ruby file, can you ask Pry what the name of the first unicorn is? Is it gonna give
So
us?
let me do this. I'm gonna comment this out, and while we're talking, I learned that load should do the trick instead of require. Load will like just reload it. Unicorn. Okay, load won't do it. So let's do that. Unicorn. That. And it does this. It says that I don't know anything about a name method. I can't. There's no way to access the name without this kind of method created to do it. We see it when we type in here, but there's no way to really access it.
Interesting.
In order to get the attributes out of a object, we need what's called a reader method. We are reading out the contents of the instance variable. That's why we need to do it this way.
Okay.
And when I do that, yep. Cool. Alexander, is that a new hand or an old hand?
New hand. So
cool.
I just wanted to follow up on that. If you define def name, that allows you to basically take name out of unicorn.rb and use it elsewhere. Is that correct? And and above it's just like at name, and you can use it within that file, but you can't use it outside of that file.
This is the terminology I use. Like we are by creating this method name, we are creating an external interface that will allow something from outside to go get that thing's name.
Cool.
Right. And so what we're going to do is that we're going to do the same thing with color. Like that. And now you will be able to get the color out as well. So this pattern is like super, super common. And what we can do is that also thing I want to show you is that we can also have attributes that every single unicorn has without it coming in. So we could do something like this. Magical powers equals empty array. And then we can do a def magical powers. And essentially what I'm saying here is that a unicorn, when a unicorn is created, it's going to have magical powers, and it's just going to be an empty array for now because a unicorn does not come with any magical powers, but it has the ability to add them a little later. Cool. Questions about this so far? All right, let's take a Pomodoro break. Let's come back at 10:09. 10:09. Recording. So we've got our unicorn. It's got some powers. It's got a color. It's got a name. Dougie?
Just real quick question. Does magical powers need to be put up as a parameter? Or why wouldn't it need to be? Okay.
Like what if we have like a default value where like this will always be an attribute of it, right? Like for unicorns, we're saying that all unicorns can have magical powers. It's just empty for now. We can think of going back to this kind of car example. We could set it so that every single car object has number of wheels equals 4, right? We don't have to tell it that it has 4 wheels. We just kind of assume like it's always going to have 4, right? And so we start off. So that's why we can have. We're essentially setting a parameter that does not come in through. We're setting. I'm sorry. Let me rephrase. We're setting an attribute that does not come in as a parameter. It's kind of like this is how I would say like setting a default parameter.
I got you.
That all unicorns have magic powers, or like I guess we could do something like perhaps at hair length equals long, right? Like we're just gonna assume that all unicorns have long hair. I don't know why, but that made sense in my head. And we'd create a thing like that. But what's the problem with this? With doing it this way, Claudia, what are your thoughts?
And pry, isn't it just going to return like all those attributes for whatever unicorn, and it's kind of going to look messy?
A little messy, yeah. A little messy is right, but like the idea is that for every single kind of attribute we have, we're gonna need to make another method, right, to do this. Like for example, if I did that, I brought hair length back, we'd have to do def hair length, and it's gonna return hair length. And I don't know how to spell hair length, and it's like, yeah, and like you can see like already with 4 attributes, we're hitting 23 lines of code, 24 lines of code. Presuming for every single attribute that we add in, that's going to add another, call it 5 lines of code. We can see how this gets like real long, real quick. And the idea is that we want to be efficient. And because this is a pattern we're going to use all the time, Ruby gives us a tool. And that tool is called Adder Reader. I'm going to take the hair length out because I don't really want to deal with hair length right now. And what we can do is that we have the syntax called Adder Reader, and it looks like this. Name. And when we do this, we can just delete this. Like so. This Adder Reader syntax creates us what I had done earlier, what we call like these reader methods. This Adder Reader syntax just does that for us and does it under the hood, so we don't have to deal with it. So now, every single time we add an attribute, we just like add one here, initialize, and we just add a line here, and it's going to be a lot cleaner. And the functionality between this and oops, yeah, like these 3 lines of code here replicate the functionality of these 10, 11 lines of code. Right, so because I have that there, I can just take this away and it will still work. Andrew?
Yeah, I feel like in practice, I can often, I guess, intuit when to use an adder reader instead of fleshing out methods for instance variables. But is there a rule of thumb for when you would want to use an attribute reader or writer instead of,
yeah,
like you said, like using methods for the instance variables?
Yeah. The idea here is that when we are using our Adder Reader, it's looking for very specific syntax. Like when we do a colon name here, that means the attribute, the instance variable has to be at name, and the method creates, it's going to be dot name. Like these all line up. this is like kind of like the power of Add a Reader. However, if you need to do things like create things that are non-standard, where the method name may be a little different, that's when I would create my own like kind of custom reader method.
Oh, sorry. Could you say that last part again?
When I want things, if I want to make like a reader method that doesn't match up, like if instead of like if I wanted like if I wanted to run say like instead of unicorn.name, I wanted to do unicorn dot what's my name. That's when I would make like a custom method instead of using Add a Reader. But usually the standard is like, hey, if the name is stored in the @name instance variable, I'm going to make a method called name, and Add a Reader will take care of all that for us.
Thank you.
Lee?
Is it just preference of organization of having your Add a Reader stacked versus on one line, or is there a difference between having name, color, magical powers on one line?
Functionally, there is no difference. Usually people will stack it because like we would rather have our code long over wide, because we can like we want to think about like, well, what happens if I have like 10 things? Like that becomes like a really, really super long line, and it's really hard to read. Whereas when they're stacked like this, I see like, name, color, magical powers, check. Some people alphabetize. I think that like for me, I just go in whatever order the things are in initialize. Is how I do it. Some people I don't know.
Awesome.
I feel that people that alphabetize that, it's like, why? I feel it's more confusing in the long run.
Okay.
Let's do
Thank you.
Con. Yeah.
Hey, so your point about how you want it longer than you want it wider. So is it just safe to assume that not everybody's going to have soft wrap enabled on their code editor?
Not necessarily. The reason why we generally optimize for length as opposed to width is generally I feel that people have an easier time understanding things, because when you do things, when you optimize for length as opposed to width, you are breaking things up in a more logical manner, and I think that like for humans, it's easier to process. It's easier to process line by line in that regard. I think that if you have something that's like 100 characters wide, that's just like it's very difficult to understand. Also, like generally the standard is that we try to keep to under 80 characters wide. That is a historical thing where screens used to be only 80 characters wide. So in general, we want to stick to 80 to 100 characters wide.
Thank you.
It just turns out like that's like kind of like the optimal kind of width. Galen?
Yeah, I just want to clarify, do you want all of your instance variables to go ahead and be in initialize? So like if I had 10 things, like 10 attributes, I would put them all in initialize?
In general, yes. I would, yeah. In general, you initialize is something that gets run every single time we create a new object. So if you need to have attributes, that is generally where we want that to happen. There are always going to be situations where that may not be true, but those are rather the exception rather than the norm.
Okay.
And as you get more familiar and more used to working with how initialize works and how attributes work, you'll be able to make that kind of decision on your own. Alexander? New hand. Cool.
New hand, yeah. Sorry, I don't have my headphones in.
It's okay.
I'm echoing. Magical.
Sorry. Magical powers is not listed after the initialize. You have like define, initialize, name parameter, color parameter, and magical powers is not included there.
Yeah,
when would you?
Powers is being passed in.
Magical. Say that again.
Magical powers is not passed in with initialize. It is just created to be an empty array.
Could you explain that further? I'm not following. So I guess my question is, like, how do you call on magical powers if it is not kind of, in those parentheses, like, it's like it would be like the
Still
third
something.
item.
Magical powers, as we initialize it, is an empty array. So we're getting an empty array back. I think this will make more sense after the next step when we add magical powers.
Okay, I'll just wait. Thanks.
So let's pause until that, and then we'll circle back and make sure that hit that understanding for you.
Okay.
Yep. Cool. Any other questions before we move on? Fantastic. So to kind of piggyback on to what Alexander was saying, is like, hey, we have this magical powers, and it's currently an empty array. And like the way my kind of like the big picture in my mind is what I want to do is that I want to give every unicorn to have the ability to have a set of magical powers that it can do. But I want the unicorn to start with none, and I want to be able to add powers after the fact, because like every unicorn is magical and unique, and they have different powers. And I want to show you what we can do to kind of model this idea that we can change attributes. To go back to the car example, like, can we not change the fundamental attributes of a car? Can we not repaint a car? A person, when they get married, may change their last name. A person may hate their first name and want to change that. There are lots. I think that when we think about, like, when you adopt a dog and from the animal shelter, and they have like a really lame name, and you got to give them a cooler name. Like, we are changing attributes of an object, and we want to give ourselves the ability to do that. So what we can do here is that, like, how do I want that to happen? Let's use our example here, and this is like a little bit of that dream driving. Like, how do I want it to work? Like, well, if I want to add a power to a unicorn, like, I want to make a method we interact with our objects using methods. So I would do something like unicorn 1 dot add power, right? Because we're adding a power, so it makes sense that the method name would be add power. Anyone, give me a power we want unicorn 1 to have.
Fly.
Rainbow lasers.
Fly was first. The rainbow. We'll do the rainbow lasers next. And we're gonna do add power fly, right? And the idea here is that when we run this method, when we run this code, it's going to complain to us, and it's going to say like, "Hey, we have a problem here. I don't know anything about about an add power. Like, I don't know anything about an add power method." So we need to make a method called add power. Oh, cool. And because we need to tell the add power what power we're going to add, it's got to take an argument power. So now this add power, what it's going to do is it's going to modify my attributes. We are taking the fly power, and we are going to add that to magical powers. And we do that like so. We use a shovel operator, which means like, hey, put this inside. And it's like this. So when I run pry here, I'm going to first require unicorn true. I'm just going to copy and paste to make my life a little easier. Right? And then I'm going to, what I can do here is that I can do unicorn 1 dot magical powers, and we see here that unicorn 1 dot magical powers returns us an empty array because we've initialized it with an empty array. We have not done anything to the powers. Right now, all we've done is create a unicorn, given it a name and a color. So it's unicorn. I need to make sure where my cursor is when I start typing. Unicorn 1 dot name. Its name is Sparkle. Unicorn1 dot color is its rainbow, and it has no magical powers. We're using this array to model the fact that this unicorn has no magical powers. We tracking? So, unicorn no magical powers. Let's add some powers. Unicorn1 dot add power, and it's going to fly. Right? And then we see here that it returns us this, and if I do unicorn1 dot magical powers, I see now that instead of having an empty array, which is what it started with, because I've run the add power method and I have sent in fly as a string. Oops, I accidentally did this away. Sorry. I have run the add power method, and I've passed in fly as a string. So what happened is that we added that string fly into magical powers, and now when I access the magical powers, it stored that information. And that attribute has changed. It can now fly, and because we're using an array, we could do more things. We want to give it rainbow lasers. We can do that. Unicorn1 dot add power. Rainbow lasers with a Z? No, 2 Z's because it's cool. And we do unicorn1 dot magical powers. We can see that it can both fly and have rainbow lasers, and we can keep adding powers, and we can keep doing the thing. We initialize this with an empty array because, you know, our intention was that, hey, this unicorn is going to have multiple powers, and usually our standard collector kind of thing to hold multiple things is this array. Alexander, looping back to what you were saying, does this kind of like clear up what we're doing, kind of like intent from before?
I suppose so. I mean, theoretically, couldn't you have magical powers in quotes?
Yeah.
After, or not in quotes, in parentheses after initialize. So then it would be the third item, and then, but it would still be, it would still be an array. So you'd have name parameter, color parameter, and then magical powers.
Yeah. So what we can do here is that, yeah, let's go down this road, right? Let's say we have magical powers like this, right?
And you just added an M to color parameter.
Yeah, thank you. So we can do this, right? But the thing is that now, every single time we initialize a unicorn, we have to add an argument of that empty array.
Okay.
Right, and oops, I deleted the thing. And the thing is that, like, that gets a little tedious, and that gets things a little long. If things are going to be the same thing, then we want to do it the way it was. We want to kind of like narrow down how many things we're passing through, especially if they're going to be defaulted the same way.
Okay, so that's how you decide whether or not to do that. Is just whether or not you want to type it in for each one.
That is one consideration. There are others, but like for right now, yeah.
Okay. Cool. Thanks.
Cool. Claudia?
Yeah, kind of going off of what Alexander was saying. So when you add the magical power, doesn't it just save to the pry and it's not necessarily saving to your runner? Is it like not necessarily important that it saves to the runner then? Is if you're using the pry for the magical power, like?
I would put that in here. Like, so the thing is that what I'm using pry for here is that this like it's just a playground where I could test things out.
Yeah.
Right. If I wanted to actually create, I wanted to have the magical powers be permanent, I would do that here, 100%.
Okay, gotcha.
Dot add power rainbow lasers. Totally. If I start a band, that's going to be the name of it with that many Z's.
Right, and then if you like save that and then went to pry and you said unicorn _1 dot magical powers, it would bring up.
100%, exactly.
Okay, gotcha.
Exactly. Cool. Yeah. I kind of want to emphasize, like, we're using Pry as this, like, free playground where we can just test stuff out. Like, Pry is an invaluable tool to just, like, try something and see if it works. Cool. Other questions?
What did you say the line 5 on the unicorn side was called? The symbol to add powers to magical powers.
Oops.
Under add power method.
This year?
Yes.
This is called the shovel operator. Essentially, it just like takes a thing and puts it into an array. It's just like Ruby has what we call syntactic sugar, things in it that just syntactical tools to make things look like when as someone like now that you've seen this, like it makes sense. Power goes into magical powers, right? That's an array. This here is exactly the same thing. These two lines of code are functionally the same thing. It's just that some people think that this is kind of like easy to understand because you see what's happening a little bit because the arrows are kind of denoted. Other people use push. I do not care what you use. I'm trying to use this syntax more, just like to change things up a little bit, but like they are functionally the same thing. It doesn't matter which one you use.
Gotcha. Thank you.
Cool. All right. We can also use the last thing I want to talk about is that sorry, we have more hands. Claudia.
Sorry, that was a mistake. I didn't put down my hand.
Okay. Kevin?
Hi, yeah, it seems like Pry is a really good way to try new things like adding using methods, but it seems like you have to input a lot of things again. Like you had to input unicorn 1, you have to input the require file. Is there a way to because you're not running Pry from the runner or like a test file, is there any way to avoid having to re-input each unicorn and everything?
Yeah, so like normally I would just run the runner file, but again, because it's not working on my computer right now, we're just doing it live. Normally I would just keep running the runner file to demonstrate this, but that great observation. Yep. Cool. Bum bum bum. Cool. So the last thing I want to talk about is like this idea of object interaction, right? And what we can do is that we can have power objects. And I'm going to save this, and I'm going to make a new file. And in the interest of time, I'm just going to copy and paste this. And this is just a power class. It's taking in two things: the name, energy required, like so. And I want to show you, like, the thing is that, like, the power of object-oriented programming in Ruby is that we can make objects interact. Objects can hold objects, that can hold objects, can hold objects. We get into this situation where, like, how we work is essentially how we work is that we're always in this land of nested objects, and we have to be. It's an important skill to be able to think of terms of where we are in the structure. I remember, like, this is kind of like, I think this is going to be super useful of remembering where you are in this sequence of nesting these nesting Russian no, Russian nesting dolls. And I think that this is also why that LSAT problem that you did during your interview is such a good indicator of how well you can program, is because during those LSAT problems, you have to hold like multiple pieces of information and reason about the same time. This is kind of like the same thing. If I have this power object here, and I'm going to require /power, what I can do is that I can do power equals power.new rainbow, nope, it's a name, so its first name is going to be rainbow lasers. And it's going to have energy acquired. Call 100, just arbitrary number, 100. And what we can do here is that we can pass the object in like this. So I'm going to run pry. And I'm just going to copy and paste this. I've added the power. So if I do unicorn 1 dot magical powers, I can see here that this returns me an array of a power object that is the rainbow lasers. Then I can start chaining things like unicorn 1 dot magical powers dot first dot name rainbow lasers, or I can do the first dot energy required 100. Right, so now we're starting to create ourselves this object that lives inside another object. Kevin, old hand, new hand? I'm going to assume that means old hand. And so this pattern here is very similar to your project, where we have a deck object that holds cards. This unicorn object holds power objects. A deck object holds card objects. And the idea is that we want to remember where we are in the stack. We are starting to nest these items. Any questions that you have about this? It is okay if it is new and foreign and scary. Dougie?
Sorry, I was trying to catch up. Why
That's
or how did we get to the point where we could chain Unicorn 1 magical powers and it register from the power class?
Yeah, so let's kind of dig into this, right? We have Unicorn 1. Unicorn 1 returns us the unicorn object, right? And so we can call on this unicorn object, we can call the magical powers method, right?
Mm-hmm.
Magical powers is this array of powers, and evidently I've added it twice. That's fine. So, because this is an array, I can do unicorn 1 dot magical powers dot first. The first method when called on an array gives us the first item in an array. So when we do this, that is the power object, and only the power object. And because I have a power object, because this is essentially an abstraction for that power object, I can then call name on that to get me the string rainbow lasers. And a bunch like this in the Ruby exercises, like we start to handle the stuff in the objects and methods exercise. So if you want to get a better handle on this idea of nested objects, do the that thing. Let's finish it up with Alex.
I'm not even sure what my question is, so I might just go ahead and say, well, so you said that it brings back the first part of the array.
Yep.
And it's the power array, but there's something that you said where I was like, wait, what?
The first method, when called on an array, returns the first item in an array.
Right. Where's the array you're referring to? Really
The array I'm referring to is the unicorn1.magicalpowers.
Okay. Which has nothing to do with what's in runner currently.
No. Well,
it out.
I used the runner I copy pasted the runner to give me the things.
Okay, no. So if I was looking at the runner, I would have no idea what you were talking about, right?
Right.
Okay, never mind. Clarified.
Okay.
Great.
Cool. So as you wrap up, I want to let you go to have a break before PD. But I would really strongly suggest looking through the lesson plan for today and kind of working through it on your own after your class today, just kind of get a feel. And that will kind of help you in your understanding. And again, the corresponding kind of exercise for this in the Ruby exercise is objects and methods. I strongly recommend you complete that if you are having trouble wrapping your head around this. But you're all set. 10:45 is when PD starts for you. The link for that is in your calendar. It's with our PD team. Go forth and do good things. Goodbye.